Good morning. Good morning. Okay, let us start. Let us start. So, before we start lecture two, could you please go to Blackboard? You go to Blackboard, Learning Resources, Lecture 1, then revision questions. So could you please let us spend around 7 minutes trying to answer those 4 questions. So go to Blackboard. Please go to Blackboard, Learning Resources, Lecture 1, then Lecture 1 revision questions. So you go to Blackboard, Learning Resources, Lecture 1, then Lecture 1 revision questions. You will find 4 questions. Could you please spend around 7 minutes? You could talk with your friends, you could discuss before. After 7 minutes, I will try to answer the questions. But please try yourself first before I show you how to do. And maybe because we don't have much time, you don't need even to show me the final answer. But if you know the process, if you know how to calculate, then that would be enough. If you just put x divided by y plus x, if that is the answer, then it is simply a matter of putting the numbers. So please, you could discuss with your colleagues sitting behind you. So let us spend around 7 minutes, so probably until 7 or 8 minutes past. So did you get those questions? Did you get the questions in Blackboard? So you go to Blackboard, Learning Resources, Lecture 1, then Lecture 1 revision questions. You will find 4 questions. So let us spend around 5 minutes from now. And you could talk. You could discuss with your colleagues if you want. Those who don't have any mobile or iPad, you could just look to your friends. You don't need to give me the final answer, but if you try to show me how the question could be answered, that would be enough. And when I try to show you the solutions, you don't need to write the solutions because I will upload them once we finish the lecture. So we will try to do as much as possible every new lecture by doing revisions from last lecture. So next week we will do a couple of questions from lecture 2 before we start lecture 3. It doesn't matter if you are wrong in answering the question, but just try. So if you see the first question, I pulled that first question from the survey that you did. So please, those who haven't done the survey about the questions that I asked, could you please do those surveys so that we get enough information? So we will use those information for your project questions and partly also for your mid-semester or final exam questions. So the first one is typical questions that is collected from your data. So those who just come, please go to Blackboard, Learning Resources, Blackboard, Learning Resources, Lecture 1, and Lecture 1 revision questions. You could work together if you want, because that would. Don't try to answer until the final solution, but just if you put the process of answering the question would be enough, which means that you already know how to do that. Okay, because we have so many slides for lecture two, let us stop here and try to answer the question. Would you be able to do the questions if I release the questions ahead of, a little bit ahead? Or you don't have time to do? For instance, if I release these questions exactly at 10 a.m., but what about if I release at 9:45? Do you think you would have time to do them before you come to class? Because if you are in another class, you wouldn't have any time. So let us stick simply that I will release the questions at 10. We will spend around 10 minutes. Okay, let me try to answer the questions. So the first thing, that given that the student chosen is male, this is conditional. Given that the student chosen is male, what is the probability that he lives near St. Lucia? The probability that he lives in St. Lucia, given that the person is male. So the first thing that you have to do is that you just put it in a 2x2 row and columns. So I took the information here and I just construct this one. The probability of female, 60, probability of male. So those red are the ones that are given. Red ones are given. The probability of female in live near campus, 0.45. 70% also it's given of the student live near St. Lucia. So red ones are given. So the question is that given that the student is male, what is the probability living near campus? So how do we calculate? we calculate this is the probability of L and C and M divided by the probability of M. So an important thing in this question is just to know how to formulate the question. So red are given. If this red is given, I calculate this is 25%, so the rest is fine. I put the rest because after I calculate everything. So let us do this one. The probability of living near campus given that the person is male, LNC and male divided by probability of male. LNC and male, because I have this 0.45, I can have 0.5 male and LNC. Then probability of male is given also, because we know probability of male is 40%. Then this is the answer. Let's go to the second question. So you don't need to write this one because I will upload once we finish the lecture. Let's go to the second question. Are being male and living, so male and living near St. Lucia campus, male and living near St. Lucia campus are independent or not? If you remember in my lecture note, I gave you how to test. If two events are independent, this is what I gave you if you remember. This must be fulfilled. To say that it is independent, probability of A given B must be equal to probability of A, or probability of B given A must be equal. If they are equal, then it is independent. If not, it is not independent. So the question is asking that, are being male, this could be male, and living near St. Lucia, L and C. So instead of A, B, you put male and living near St. Lucia. So either this must be equal to this one, or this must be equal to this one. So let me first calculate this one. I will calculate this one because I already know this one. Probability of male is 40%. Let me calculate this one. I don't need to do this because if this is not equal, I don't need to do this one because I have already answered my question. So let me try to do this one. Probability of M, LNC, given M, LNC, is probability of M and LNC divided by probability of living near St. Lucia campus. M and LNC, male, 0.25. Probability of LNC, 70. So I got 0.36. They are not equal. So they are not independent. They are not independent. If they are equal, they are independent. If they are not equal, they are no longer independent. So this is not independent because they are not equal. So you don't need to try the other one, so because it is OR. Let's go to the second question. This is, what type of question is this? Those who read. What type of question is that? Addition, multiplication, conditional, what type of question? What type of question do you think? Not only I ask you the type, not the answer. What type do you think? Bayesian. This is a Bayesian type of question. We have a prior information or prior probability. We have new information. New information means conditional probability, and the question is to revise the probability, which is Bayesian. Let's go quickly. Solution. Assume D equal to defective. Let us say D is defective. Information given, probability of A, 0.40, B, 35, C, 25. Now, the percentage of defective tire are 2% of brand A. Given that it is brand A, the probability of defective is 2%. Given that it is brand A, the probability of defective is 0.0. Given that it is B, the probability of defective 1%. All this information is given. The last question it is asked, if the company selects a tire and finds it defective, so given that it is defective, they found it defective. Given that it is defective, what is the probability that it is a brand C type? What is the probability of C? Given that it is defective. So the question asked is the probability. So this is prior probability. All these things we call it prior probability. All these things, the one that we said new information or conditional probability. And now the question is that we want to revise this one using this one. So this is the posterior or revised probability. If we have a prior probability and if you have new information, it is possible to revise this probability. In this question, we can revise this probability. So we know how to calculate this one, the formula that I gave you, probability C given D. Probability C given D is, we exchange this one, DC, probability of C. We put the whole here, and we add the rest. Because defective could be from C, defective could be from B, defective could be from A. You remember that? Because last week we did only 2. But it depends. Here we have 3 tire companies. So the easiest way probability C given D is that you change it D given C times probability of C, put the whole here, and then add the rest. Defective from C times defective from C, defective from B, defective from A, then it would be 39.5. So we revised this one. We revised this one. Okay. Let's go to the other question. You remember rule 1, rule 2, rule 3, rule 4. Which rule do you think the first question? A. Rule 1, 2, 3, 4. We did 4 rules last week. The first question, which rule do you think? It's not talking about subset. If you remember last week, I was saying that there are 3 places in how many ways these 3 people could sit. So the first question, if a set of 8 textbooks is to be placed, so 8 in 8. So that is not a subset. If it is a subset, you could think, oh, maybe permutation, maybe combination. So rule 3 or rule 4. But this one is rule 2. So the first question is rule 2. Simply it is asking 8 factorial. 8 times 7. Now here you come, when we come to B and C, it is 8 and then 5, a subset. 8 and 5, a subset. The question looks a little bit similar. Now you might be confused. Shall I use permutation or shall I use combination? You might be a little bit juggling. Which one is the best? I will give you a little bit of information how to differentiate. Keep in mind, most of the time this is arranged, this is choosing. Last week I told you, if you remember, that additional information I give you, a chairperson, a vice, and then order matters. If you say only 3 people, order doesn't matter. But there is also additional information which you could differentiate between permutation and combination. So the second question is permutation. Because it is saying arranging, this is choosing. So in a permutation, we know the formula. This is the formula. N factorial is 8. You choose 5. The third one would be combination. This is the formula. And now you would ask definitely, how do I differentiate between B and C? So generally, this could be used. The first one, number of ways that N items in order. The second one, number of ways of arranging 5 out of 8 in order. Here we don't care about the order. Number of ways of selecting 5 out of 8 irrespective of the order. So whenever most of the time it says selecting, choosing, this is combination. If it is saying arranging, that's most of the time it is permutation. In addition to the information that I gave you last time. Last time, if you remember, I gave you a chairperson, chairman, vice chairman, secretary. This is order matters. Order matters. But if you say only 3 people, irrespective of their position, irrespective of order. Okay, let's go to the final question. A final question is a binomial type of question. A hotel claims that 90% of its customers are very satisfied. N equal to 6, less than 6. Less than 6. The question is about satisfied. This is satisfied, this is satisfied. So P equal to 90% and Q equal to 10%. N equals to 8. So the question is asking less than 6, probability of 0, 1, 2, 3, 4, 5. So which way do you think it's easy to calculate? I prefer calculate the other way, yeah? So less than 6 means I calculate 6, 7, and 8. Then 1 minus. So I calculated, this is the question. So I calculated first 6, then 7, then 8, then 1 minus the summation of all these 3. You could do it probability of 0 plus probability of 2, probability of 3, probability of 4, probability of 5. You could add all of them, but I think the other way is more simpler. Okay. Now let's go to today's lecture. So if you remember, we did this one, discrete. 1, 2, 3. How many television in your house? How many friends do you have? It is all discrete. We did binomial. Now we will do Poisson. We will do hypergeometric. We will come to continuous. Continuous means like income, like weight, like height is continuous, because you could have a lot of decimal places. 1 meter and 25 centimeter, 1 meter 25, 26, 5 centimeters. So there are a lot of decimals, continuous. In the case of continuous, we will talk about normal, uniform, and exponential. So let's start with Poisson. But before that, a discrete, things that you count, 1, 2, 3, it could be finite or it could be infinite. Finite means the number of students are 260. So the maximum would be, it is countable, 0, 1, 2, but we know the maximum. In the second case, it is countable because we could count 1, 2, 3, 4, but it is infinite. The number of customers served at a hotel reception. It could be 2, it could be 10, it could be 20, it could be 1,000, we don't know. So it is, you can count it, but it is infinite. Binomial, we spoke about these things, I don't need to repeat. But binomial, it is countable. You flip a coin 10 times, countable. 11 times, countable. And it is finite, because n is given. I say, I flip a coin 8 times, so it is finite. It's not infinite, because n is given. In the question here, n is given. So it is finite, and it is countable. Now let's go to Poisson. The most important about Poisson is the number of occurrences or the number of events in a given interval. Always given interval. An example, the number of customers in 1 hour. How many customers do they come in 1 hour? So interval of 1 hour, the number of customers is 0, 1, 2, 3, 4. Number of industrial accidents per month in a given period of time. Events means occurrences, number of bankruptcies in a month. All these kind of things, you count them, but in a given time, it is Poisson distribution. So it is countable, infinite. Why do we call it infinite? Why we call it infinite? Because within 1 hour, so many people could come. We don't know how many people would come. We don't know how many accidents could happen. It could be 10, it could be 100. So, I put these things, maybe it is not in your lecture note. The probability an event occurs in any interval is the same for all interval of the same. The probability of, for instance, the interval is between 10 o'clock to 11 o'clock. The number of customers coming from 10 to 10:01 is the same like the probability from 10:01 to 10:02, from 10:02 to 10:03. 10:03, 10:04. The probability would remain the same for the same interval. It could be from 10 to 10:30, from 10:30 to 11. The same, the probability would not change. The probability of an event could be the number of customers coming in any interval, is the same for all intervals of the same size. The probability customers coming between this interval would be the same probability coming between this interval if the interval are the same size. The second one, the number of occurrences of the event in one non-overlapping interval is independent. Let's say, for instance, between 10 to 12. Between 10 to 12. The number of people coming from 10 to 10:30 doesn't influence the number of people coming from 10:30 to 11. The number of people coming from 10:30 to 11 doesn't influence the number of people coming from 11 to 11:30. So the other one doesn't influence the other. The number of occurrences is independent, means non-overlapping, means from 10 to 10:30, and from 10:30 to 11, it is non-overlapping, it is separate. 10, 10:30, 10:30 to 11. Because many people come between 10 to 10:30 doesn't mean that few people would come from 10:30 to 11. So it is independent. The third one, the probability that two or more occurrences of the event in an interval approaches zero as the interval becomes smaller. Who can tell me this concept? What does it mean? What does this one mean? So this one would mean, let's say that the interval is between 10 to 11. Between 10 to 11, how many customers would come? Now, if I make this one is very small, between 10 to 10.0001, how many people would come? Almost none. So if you make it very small, nobody would come. So that is what it meant. A little bit information I gave here. Assume X number of customers arrived at a checkout counter of a grocery store in 1 hour. It is reasonable, so I am explaining the first and the second. It is reasonable to assume the probability that a customer arriving during a 1 hour interval is the same as the probability for all other 1 hour intervals. 1 hour interval, 1 hour interval, 1 hour interval, the probability would be the same. The second one, the arrivals of a customer during a 1 hour interval, here, let's say, has no effect on the arrival of any other. The arrival here doesn't affect the arrival here, or doesn't affect the arrival here. It means that because in the morning there are many people, it doesn't mean that less people would come during lunchtime. So let's go to how to calculate. This is the formula. This is the question. This is the average number of events, lambda, mean number of occurrences, mean number of events per unit of time. The mean number of events per unit of time. This one is the exponential figure, also it's given, natural logarithm. So this is the formula, and this is the question. Before applying the formula, let's go to one question. Anna is concerned about staffing needs at the Starbucks that she manages. She has specific questions about the probability. Let me go directly here. Anna believes that the typical Starbucks customer average 18 visits 30 days. In 30 days, 18 visits. The question, what would be in 10-day period? So it is simple. If 18 in 30 days, in 10 days, how many? It would be 6. Now keep in mind, the question that I am asking, this is the question. This is the X. This is the X. This is the question. But keep in mind, I am talking about 10 days. I am not talking about... So, if you try to answer this question, are you going to use 6 or are you going to use 18? We have to use 6 because the question is about 10-day period. And the 10-day period is already... So in my question, in my exam, sometimes I might give you in, let's say I might give you in months, but my question could be in day. So you have to convert. You have to make similar. So the first question is simple. Now let's go to the second question. What is the probability that a customer visits the chain 5 times in a 10-day period? So we apply the formula. This lambda is the average, is already given. 6, this minus is always there. So we put 6, and this is already 6. This is the question. This is the question. So we calculate. The variance of a Poisson distribution is equal to, so the variance and the mean, because this Poisson is the mean. So the mean and variance would be the same in the case of Poisson. The mean and variance, because this question could be asked in true-false questions. In your mid-semester or final exam, you would have true-false questions. So simple things like this, please take. Okay, so this is one type of discrete distribution. Hypergeometric. In the hypergeometric, you remember that when we flip a coin 10 times, P and Q would be, what is P? 0.5, 0.5. You flip 10. What about if I flip 20 times? What is P and Q? What about 30 times? The same. Here, it's not the same. It changes. Why? Because without replacement. So, P and Q would not remain the same. In the binomial, it remains the same. Because wherever you flip the coin, P and Q is the same. Hypergeometric distribution trials are not independent. They are dependent. Success and failure, P and Q, change from trial to trial. In a binomial distribution, sample data are selected with replacement from a finite population. What does it mean with replacement from a finite population? This is fine. Finite population. You remember here? We said finite, binomial. But now I am adding a little bit additional information. This is fine, I explained. Flip a coin 10 times, finite. It has some limitation. It finishes. But here I added a little bit additional information. Or without replacement from an infinite population. What does it mean? You remember? Binomial, P and Q remain the same. Here, when I am trying to explain binomial, I added additional information. I said, or without replacement from an infinite population, without replacement. Do you think P and Q would remain the same in this statement? In this statement? Do you think P and Q remain the same? Constant? The idea is that, let's say I have 1 million students. I pick one student. What is the probability of that student? 1 divided by 1 million. Then that student would be set aside without replacement. Now I am picking another student. What is the probability? 1 divided by 1 million minus 1. Do you think the probability will change much? Do you change much? Whether you divided 1 by 1 million or 1 divided by 1 million minus 1, it doesn't much change. So P and Q would remain the same with infinite. So that is the idea. So in the case of hypergeometric, how could you differentiate the question? Usually, in the previous question, it is only n is given. How many times is n in binomial? N. It's not capital letter N. It is the size of the sample. In the hypergeometric, you need n, which is capital letter N, which is the population size. N small letter is the sample size. So this information is important. N is the sample size. N, the population size. A is number of success in the population. For instance, number of female in the population. N minus A, number of male in the population. So if this is number of female in the population, this one number of male in the population. And this one is the question, number of male in the sample. If the question is about female or male, we put it success, failure. It could be male, female, it could be yes, no, it could be defective, not defective. So let's go to this question. 24 people, of whom 8 are women, apply for a job. If 5 of the applicants are sampled randomly, so let us stop here. What is the sample size? What is the population size? 24. What is the number of women in the population? 8. So A, capital letter A, is 8. What is the probability that exactly 3 of these sampled are women? And this is the question. So we have N, we have A, we have X, we have N small letter. So we have, having that, then we can easily calculate. So A, 8, X is the question, N is the population size, N is the number of female in the population. This is sample size. This is the question that we are asked. So if you follow the formula, I mean, you don't need to worry too much about the formula. The formula will be given in your mid-semester. So you just apply the formula, but you need to understand the question. So the mean of hypergeometric distribution, you could calculate this way. N is 5, A is 8, n is 24. So you could calculate it. Yeah? The standard deviation, you could calculate also. This is times. So you have n, 8. This is, no, n is 5. This one is 8. 24 minus 8. N squared, 24 squared times, you follow all this formula, and it would be 0.96. So we did hypergeometric, we did Poisson. So we finish with discrete. Now we will go to the continuous. Sometimes my slides could be a little bit different from yours somewhere. I mean, when you go through the recording, you would find it. But if you really want it, you could also ask me, then I could give you. Okay. Now let's go about continuous. Continuous, as I told you, between two lines, every number is possible. If I say your income is 10 per hour, your income is 20 per hour. If it were discrete, 10, 11, 12, 13, 14. But if it is continuous, there are a lot of numbers between 10 to 20. 10.0001, 10.0002, 10.00. There are so many numbers between the two. So that's why we call it continuous. In a number of television, it's 0, 1, 2, 3, 4. Number of friends, 0, 1, 2, 3. But if it is, let's say, income, if it is height, if it is weight. So let me go, before I go to this continuous, you remember this, a discrete, a countable, finite, or a countable, infinite number of. Countable, infinite is Poisson. How many customers? I could count them, but they could be many. This countable, finite, in the case of binomial, I flip a coin 10 times, it is finite. And I could count the number of heads. When we come here, it is uncountably infinite number of possible values. Let's go to this example. Let x, the time taken by a student to complete a statistics exam in a university. There are 3 hours exam. Then you cannot leave the first 30 minutes. You have 3 hours exam, you cannot leave the first 30 minutes. So if you want to leave, you have to leave when? Then is it 30.1 that you would leave? Could it be 30.01? Could it be 0.001? Could it be 0.0000 something? Yes, there are so many possibilities. Because time is continuous. Time is continuous. None of this I gave is the second possible value. The first one, exactly when it is 30, somebody could go. What about the second person? You see, if it says you don't leave for 30 minutes, then when it is already 30 minutes, students could leave. What about the second? Let us assume the first person left when it is exactly 30. What about the second one? Would it be 30.01, 30.001, 30.00? There are so many possibilities, and we couldn't answer the question. The only thing that we could answer is the 30 minutes and the last one. We could be for certain, we could say 30 and 180. But the second one, the third one, the fourth one, we don't know. Because numbers exist that are larger than 30 and smaller than this one. Thus, we cannot identify the second or third or any other value except the last one. So, what is the idea of this one? The idea is that between two continuous variables, let's say a continuous variable income, height, weight, between two numbers, there are so many possibilities. Now let's say the possibility between 30 and 180 is how many possibilities do you have in finance? If I ask you, what is the probability of picking one number? 1 divided by? It will be approximately equal to 0. It's almost you are 1 divided by so many numbers, which means 0.00 something. So that's why in a continuous, we will not ask a question, what is the probability of 5? What is the probability of 7? We cannot ask that question because it will be 0. What we could ask, what is the probability between 5 and 6? What is the probability less than 5? What is the probability greater than 10? That is how we would ask. So this is 0. A continuous random variable can take an infinite number of values. So if I ask you picking 1, then it would be almost 0. As a result, a continuous probability distribution cannot be expressed in tabular. You see the binomial, if you go to our textbook, for any binomial question, the answer could be in the table. So if you go to the last tables in our textbook, for any binomial question or Poisson, you could find from the table easily. But here it would be difficult to find from the table because the probability that the person would leave 30.001 is almost 0. So we cannot express in table. Instead, we can use equation. We can use equations. But most often, the equation used to describe a continuous probability distribution is, okay, this one we don't need. This one also, it's not that much, because if in a normal distribution, for instance, if you see these tails, it is simply infinite. If you have a bell-shaped, then it would continue infinite, and the other one is infinite. That's what it meant. The probability in the curve or wherever, it will be 100%. This is how we calculate, so this is not that much important. So let's go directly, having the concept of what continuous probability means. Let's go to one type of continuous variable or continuous distribution. The first one is uniform. The uniform, you see, as you could see, sometimes it is called rectangular. It is symmetrical. If it is symmetrical, you see, symmetrical means if I have a very normal curve and the middle is the mean, if they are very symmetrical, 50% here, 50% there, the mean and median would be equal. The same thing also, because it is symmetrical, anywhere half of it is equal size, then mean and median is equal. So let's go to a type of uniform type of question and how we will calculate. We have always a number between A and B. And then based on those numbers, we could calculate the probability of uniform distribution. The distribution, you see, the example, if you go from A a little bit here, the probability would be somewhere here. From that small, again, another equal size, the probability would be the same. So the probability would always remain the same for the same distance. If you go, let's say, from A to A1, from A1 to A2, the probability would be the same. Let's say here you have A1, A2, A3 of the same size. So what is the probability between A and A1? It would be around here. What is the probability between A1 and A2? Would be again the same. That's why it is uniform. Could you think of uniform distribution but discrete? This is continuous. But could you think of a uniform but discrete? What is the probability of you throw a die that it lands on one? What is the probability? The probability of throwing the die and landing on number 1. 1/6. The probability of getting 2, 3, 4, 5. It is uniform, but it is discrete. So sometimes in textbook, you could also find a uniform, discrete, a uniform. What I am here doing is a uniform, but I am not talking about a die, because a die is 1, 2, 3, 4, 5. It is discrete. What I am talking is, it could be this is flight time. The flight time would be between this and this, or the arrival time of a plane could be between this and this time. Time is continuous. So I am talking about a variable which is continuous. Uniform distribution can also be discrete. Example, rolling a die. If you have a rolling the die, the probability of getting 1, 1/6. The probability of getting 2, 1/6. The probability of getting 3, 1/6. The same, uniform. So it could be also discrete. But here we are talking about continuous. Let's take one example. Consider the random variable x representing the flight time of an aeroplane traveling from A to B. Suppose the flight time is between 120, 140. So we are making some assumptions, but this is time. Time is a continuous variable. It could be 120.0001, 120.0003 until the end. There is a lot of possibilities. The uniform distribution describes a random variable that has an equally likely chance of assuming a value within a specified range. So the idea, let us read this. Because the random variable x, which means the flight time, can assume any value between 120 and 140, x is a continuous variable because we are talking about time. If you assume that the flight time is uniformly distributed, let us assume it is uniformly distributed, then the probability of a flight time within any 1 minute interval, 120 to 121, from 121 to 122, from 122 to 123, the same interval, the same of any 1 minute interval is the same as the probability of flight time within any other 1 minute interval. 120, 121 probability would be the same, 121, 122, 122, 123, 123, 124. It is uniform. So any time between this is an example. You could make it 2 minutes, you could make it 3 minutes. But as long as you have the same interval, the probability would remain the same. That's why it is called uniform. So we are assuming that it is a uniform distribution. I am not saying that the flight time is always uniform, but we are making an assumption. Okay, so how do we calculate these things? If I ask you a question, what is the probability that the plane would arrive in 110 minutes? 0. What would it happen 141 minutes? 0. 0. So 120, 140, the minimum 120, the maximum 140. Anything outside, probability is 0. Okay. So the first thing that we need to do is that once this information is given, let us calculate the difference. The difference is 20, then 1 divided by 20, it is the density function. So 1 divided by 20, this is the minimum arrival time, this is the maximum arrival time. We have all this information. Let us call this one height. Let us this one base. So always uniform distribution, height times base. Height times base. This is the height. The difference, 1 divided by the difference, height. The base would be the question. To calculate the probability that the flight time is between 125 and 132, the base would be the difference. 125, 132 difference would be the base. The height is already we calculated. So the probability would be 0.35. To calculate the probability that the flight time exceeds 135, we know our maximum is 140. Exceeding 135 means the maximum minus 135 would be the base. The height is already calculated. So always don't forget height times base. That is the formula that I will give you in your exam. I will give you uniform distribution, height times base. You have to convert what base means, what height means. So this is also additional information. That is how to calculate the mean. This information is given. A is 120, this is 140, 120, 140 divided by 2, everything. This is always 12. So you see, anything outside this interval, A and B, anything outside would be 0. 119 is 0, 141 is 0. Anything outside this interval would be 0. This is A is always the minimum, B is the maximum time or value of X. So we calculated the mean. If you haven't done so, 130, the variance, 140 times 120 minus 120, the square times 12. Always this 12 remain constant. I don't need to do this example. This is A, this is B. The calculation of mean variance, it is very simple. So I leave that to you because the formula is already given. We know this is A, we know this is B. What is the height? The height is 1 divided 5,000 minus 2,500. So 1 divided B minus A would be the height. So I don't need to do here. So the maximum we know that 5,000. The question is between 3,200 and 3,800. So the base would be the difference because the question is asking what is the probability between 3,200, let's say between 121 and 125, somewhere in between. So what is the probability that sales exceeds 4,000? We know the maximum is 5,000. The question is exceeding 4,000. The base is 1,000. The height we have already calculated. So it is a simple procedure. But when we say uniform, the idea is in every 1 minute interval, the probability would be remain the same. 120 minutes, 121, 121, 122, 122, 123. The probability between these intervals would remain the same. That's why we call it uniform. Let's go to the third one, which we call it exponential. This is the second type of continuous, the second type. Most of the time, they call it the waiting time distribution. You see, time is again continuous. It is a waiting time distribution. The minimum is 0, and it has infinite value. It has infinite value to the right. The minimum is 0. To give you a little bit idea so that you link exponential, the length in minutes of long-distance business telephone call. So the idea is that, for instance, if you buy a telephone call and you try to call somebody who is in Brisbane, you could talk so many hours because it doesn't cost you much. As you go here, you would talk less and less because if you are trying to call abroad, then you would only talk maybe 5 minutes, 10 minutes, then the money would be gone. So that is the idea. So the length in minutes of long-distance business telephone call, the nearest the distance, the more you would talk, the probability would be higher. The more the distance would be, this could be distance. Then if you are trying to call with someone who is living very far, then definitely you wouldn't talk too much because it would cost you. But if it is you are talking with someone who is in Brisbane, you could talk many hours because it doesn't cost you. The same thing, the amount of time in months a car battery. When the car battery is new, you could use that car battery for 2-3 years. As time goes by, then the life of the battery would diminish. So after 1 year, your car battery would has less capability of remaining powerful, the car. So the amount of time in months a car battery lasts. When you buy it new, the probability that it will last 2 years would be high. Then as time goes by, then the life would diminish. So that is the general idea. So let's go. I rewrite this one a little bit from your lecture note. If you would like, you could write it this way. If x is an exponential random variable, somewhere between 0 and infinite, between 0 and infinite, it could go, this line could go infinite. If x is an exponentially random variable, 0 to this x is between 0 and infinite, then the probability that x is less, if the question is less, you have to use this formula. If the question is greater, you have to use 1 minus the one that you calculated. Or you could just simply use this formula. This lambda, the same lambda that we use in Poisson. How do we calculate? The mean could be calculated this way. The variance could be calculated. So anything less, 1 minus this E is 2.7, then lambda we will calculate, then A is the question. This A is the question. Okay, let's go to this question first. An on-the-job injury occurs once every 10 days. Once every 10 days. If you are asked to calculate the mean occurrences once every 10 minutes, 0.1. once every 10 days. So we know already what lambda is. And keep in mind, the question is about days. So our lambda always should be about days. Information given about days, the question asked days. Do you think this type of question is less than or greater than type of question? This question, within 5 days. 5 or less, so within 5. So this is a less type of question, so we could use this formula, 1 minus the whole this. So the first thing that we have to do, the A is, this is the question, so we have to apply this formula, but lambda must be calculated. Lambda is saying the mean event, the mean occurrences per unit of time. Events per unit of time. In our example, 1 every 10 days. So the mean value is 0.1. 1 every 10 days means the mean value. Don't confuse with mu. Mu here, the mean time between events. 10. One injury, 10 days. Another injury, 10 days. Another injury, 10 days. So mu here, mean time between events. Units of time per event. So please try events per unit of time. This is units of time per event. So try to differentiate between mu and lambda. Lambda is the same like what we did in Poisson. But when you talk about this one, try to differentiate. This is unit of time. It is about, the question is about time. So 10 days, about time. This is unit of events or occurrences, injury. Events is the injury. So try to differentiate between the two. So once we have the lambda, then it is easy to calculate. It doesn't really matter whether it is equal to or simply it's less than 5. Okay, so we did, the binomial is already done. We did Poisson, we did hypergeometric, we did uniform, we did exponential. Now we go to the main one, which is the normal distribution. The normal distribution is the most important one. In many things, we apply normal distribution. All of the lectures that we will do until maybe lecture 10 is we always assume it is normally distributed. So the normal distribution is the most important one. So let me say something about this one before we go to a break. So the normal distribution, it's a bell-shaped, symmetrical, 50% half, 50% half, mean equals to median equals to mode. Location is determined. The location means if you have a normal distribution, this is the location. The location is determined by the mean. The width is determined by standard deviation, the spread. Some normal distribution would like, we have different normal distribution. The spread would be determined by standard deviation. The location determined by the mean. The random variable has infinite theoretical range. Infinite means this would continue, and this would continue, infinite. The range would be infinite. So what do you observe here? What do we observe? Here, the mean is the same, but the distribution, the shape is different. So I could conclude from this one, I have the same population, let's call it this one population mean, not about sample, but population mean. I have the same population mean in these two distributions, but different population standard deviation. What about here? I have the same population standard deviation, but different population mean. So what does it mean? A normal distribution, we could have so many types of normal distribution. At least I have 2 here, 5. What does it mean? We could have so many normal distributions with different mean value, population mean with different. That makes problem to use the table. Because if you want to use the table, you should have a table. What would be the distribution if mean is 5 and if mean is 5 and the standard deviation is 2, one table? What would be if the mean is 2 and the standard deviation is 3? Another table. What would be if the mean is 2 and the standard deviation 7? One table. How many tables do you need? It would be really difficult. You could apply a formula. The formula would make also a little bit difficult because every time you have to calculate because we have different types of. Now, the question that you have to have in your mind, is it possible, irrespective of how it looks, as long as it is normal distribution, can we use one formula? Then, yes, that is yes the question. Why we are trying to use only one formula? Because it makes life easier. We don't care about how it looks like. As long as it is a normal distribution, we could apply only one formula. And we could answer any question. For instance, I could ask a question here, what is the probability from this point to the left? What is the probability from this to the right? What is the probability in between? But if I am not using one formula, it will be very time consuming. If I want to use a table for each population mean and population standard deviation, I should have to have one table. For the other, the same. So how many tables? Numerous tables, so many tables. What about formula? This is the formula. Maybe I will stop here. And let's have around 7 minutes, please. Then we will come back and finish. Okay. Okay, let us continue. Let us continue. So why is normal distribution, this normal distribution is so important? Why do we spend a lot of time, as I told you, lecture 3, lecture 4, lecture 5, lecture 6, they all based normal distribution. Why it is so important? Because many variables are normally distributed. In this world, so many things are normally distributed. The height of a person, maybe few people who are very tall, very few people who are very short, very few people who are very tall, the majority are in the middle. The height of a person, the same thing. Very few people who are underweight, very few people are overweight, the majority are somewhere in the middle. So a lot of things is normally distributed. So that is the one thing. The second one, if the question is binomial, for instance, let me ask you a question. You flip a coin 100 times. You flip a coin 100 times. And then if I ask you the question, what is the probability that the head would be 2 or greater? So you have to calculate probability of 3, probability of 4, 5, 6, 7. So it is a lot of things. But we could use a normal distribution to approximate the result. The question is binomial, but we could use a normal formula to answer the question. So a normal approximation to a binomial distribution. The question is binomial, but it might take us a long time to, nowadays a computer could do that. But let us assume that we will do it manually. If it is a binomial, and I am asking you, I flip a coin 100 times, tell me what is the probability of head 50 and over. You have to calculate 50, probability of 51, probability of 52, probability of 53. All these things is time consuming. But I could use simply a normal distribution to approximate the result. That's also very important. Then we will talk a little bit about this one later. So this is the formula. So the formula would be time consuming because for every mu, for every standard deviation you have to calculate. What is the mean? What is the standard deviation? You have to use the formula. Another distribution, what is the mean? What is the standard deviation? You have to calculate again. So calculation also is a little bit time consuming. The fact that the normal distribution shape varies with mean and standard deviation can make analysis by the normal distribution using the mathematical expression tedious. We have to calculate, recalculate again because we have so many. Using a possible solution, set of tables. But again, how many tables? As I told you, mean 5, standard deviation 3, 1 table. Mean 2, standard deviation 7, another table. How many tables? That's also difficult. Fortunately, we could use a standardized normal distribution. This is normal distribution, but we could use a standardized. So we standardize. Every shape could be standardized. The standardized normal distribution where the mean is 0 and the standard deviation is 1. Mean 0, standard deviation 1. So we could calculate any kind of normal distribution using this formula. For instance, we can obtain probability for any normal distributed random variable for any shape by first converting the random variable to a standardized normal variable using a z. That's why I told you today to bring a z table. Okay, this is the formula. Z equals x. What is x? Any normally distributed random variable. So this x, because when I do next to the half of this slide, this x would be changed to x bar, x bar. This x is, let's say this is the population. This is the whole students enrolled for this class. This x means simply picking one student, randomly picking one student. Usually we don't do like that, we take a sample. But let us assume the whole this exercise is from the population, assuming the whole this class is the population, assuming this class is the students enrolled for the course, all of them, then x means you randomly pick one. And then let's say you measure the student 170 centimeter. What is the probability that it could be less than this one? What it could be the probability of the height greater than that one? So we are only picking, this one is any normally distributed random variable, any random variable. This is population mean, this is population standard deviation. This is 0, the standard deviation score to 1. So the probability of z greater than 0 would be 50%. Less than 0 is 50%. So any z value greater than 0 has a 50%, less than is 50%. Now let us do one question. Consider a normal distribution. Any normal distribution. Consider normal distribution of one of this one. It has a mean mu is equal to 7, and the standard deviation is equal to 1.1. So the mean is 7. So you have a normal distribution. The mean is 7, and the standard deviation is 1.1. Now the question is asking, what is the probability between 7.75 and 8.25? Tell me the probability between these two numbers. So a normal distribution, 7 is the middle. So what is the probability between 7.75 and 8.25? We have this formula. Now it is easy. Life is easy because we have this one. So let's start. 7.75, where is the question? 7.75 minus 7 divided by 1.1. The other one, 8.25, which means 8.25 minus 7 divided by 1.1. What am I doing now? I am converting to z value. I am calculating z. Because this is a z formula, I want to find z. Once I find z, I go to the table, I pick the probability. I have z. Using the z, I pick the probability. Keep in mind, the z distribution in our textbook is always calculating to the left, on the left-hand side. Always tells you what is the probability on the left-hand side. Keep in mind that in different textbooks could be different, but our textbook always calculated to the left. So in your exam, the table that I will give you is the one that it is in the textbook, calculating to the left. So please familiarize yourself with those tables. Okay, so I calculated. Now I converted 0.68 for this one, 1.14 for this one. The question is, what is the probability between this and this? I calculated, I found 12.11% probability, or 0.1211. Let us do it. So this is information given, population mean 7, population standard deviation 1.1. The question, what is the probability between the two? So first I have to convert z value for this one, another z value for this one, then I could easily find my answer. You see, the x scale, 7 mu, the question is between 7.75 and 8.25. From the z scale, I already know that the middle is 0. Mean equals to 0. When I converted this one to z value, it became 0.68. When I converted this one to the z value using the formula, then it becomes 1.14. Now the question, what is the probability in the middle? What is the probability here? Now, as I told you, the textbooks gives you always to the left. So the easiest way, what is the probability from here to the left? Once I know, what is the probability from here to the left? And then I deduct. Because the probability is always tells me to the left. So the probability from 1.14 to the left, then the probability from 0.68 to the left. Then I deduct, then I will find this one, 12.11. So first I go from 1.14 to the left. I found 0.8729. Then I went from 0.68 to the left. Then I found 0.7518. So this distance would be 0.1211. You see the idea? Mu is given, standard deviation is given, population standard deviation. I have converted to z value. I converted, this is what it was given. This is given, I convert it to the Z value. I know the middle is 0. Then this is the things that I calculate. Once I have the Z scale, that Z scale would help me to find the probability. That is the procedure that I followed. How do we know? 1.14 to the left. 1.14 to the left. 1.14. 1.14. 0.8729. The other one, 0.68. 0.68. Then this minus this would be the value that I am. So always it will tell me to the left. If you want to calculate to the right, first you know the left, then 1 minus. So please try to familiarize yourself how to read the Z value or probability value from the table. Because sometimes if you don't know how to read, you could easily miss the answer. Okay. Let's go to one exercise which probably would help us also. From actual road tests with the tires, an engineer group, population mean given, population standard deviation is given. The question is more than 40,000 miles, more than 40,000 miles. We just simply apply this formula. We apply this formula. Well, let us use this formula. 40,000, the question, the population mean is given, the population standard deviation is given, Z we calculate. The question is to the right. So what should we do? First we go to the left, then 1 minus that. Okay, so in other books probably you could do, but in our textbook you couldn't. Okay, let's go to this question. Question, the probability X greater than 40,000 miles. Information given, mu 36,500, population standard deviation, this is population mean, population standard deviation 5,000. We apply this formula. 40,000 minus 36,500 divided by 5,000. Keep in mind, the question is greater. X scale, this is the mean. Population mean, 30. This is the 40,000. When I convert, this is what I got. The question that was asked greater to this one. Because it is difficult from the textbook, first I go to the left. Once I go to the left, then if you want to find this 2420, 0.2420, first you go from 0.7 to the left. And then 1 minus that probability value. Because the table doesn't give you a probability to the right. Only it gives you to the left. If you want to, we know that the whole this is 1%, 100%. We know the whole this is 100%. So in the textbook, you go from, in the table, you go from 0.7. So you know all this probability. Once you know this one, if you want to know this, 1 minus that value. So that is easy. Huh? So this is how I calculate 0.7. The X scale is already, the information given is X scale. The Z scale, I know that the mean is 0. Then I calculated 0.7. The question is asking, what is Z greater than 0.7? In order to find Z greater than 0.7, first I try to find Z less than 0.7 because our textbook table doesn't allow us to do to the right. Okay, so I want to know this one. First I go this way, but the question is here. I want to find this one. So I go this way because the table always tells me to the left, 0.7. 71. So the whole this is 7150. The rest would be 1 minus. This would be 1 minus. So keep in mind the whole this exercise that we are doing, assuming this is the population, we pick only 1%. And then we say that, for instance, if it is about height, I pick 1% randomly. The height is 1 meter and 70. What is the probability that it would be less than 1.70? What is the probability that it would be greater than 1? What is the probability that it would be between? So I'm only picking one random variable from the population, not a sample. because in real terms, you don't pick only one person, you take a sample. So in our later discussion, keep that information in mind. This is now, you see, what we do here. You have Z, then you calculate the probability. What about if I give you the probability? Could you calculate Z? Could you give me Z? I give you the probability, I give you 0.7580, you give me 0.7. So the other way around. The area to the left of Z is 0.2119. The area to the left of Z is 0.2119. Do you think Z is positive or Z is negative? Huh? So I will give you the answer for this one first, because try to do this one at home. But if the question, I will do the first two. If the area to the left is only 0.2119, do you think Z is positive or negative? It has to be negative. So please copy this one if you want. Okay. So the first one, I'm doing the first two. This is between, this is to the left. I already taken, this information is given. If I got this information in my mind, I know immediately Z is negative. You have a table Z positive, you have a table Z negative. You have two tables of Z, positive and negative. I don't need the positive now because I know already it is about. So I go to the negative one, I try to find 2.119. So it is minus 0.8. Z is equal minus 0.8. Sometimes if it is not exactly 2.119, if it is 2.118, still you could take this one, yeah, the nearest. Doesn't matter. The second question, let me go to the second one. Between, the area between two values, the area is 90-30. Do you think Z is positive or negative? So you have a normal distribution. The middle is 90%. What would happen then to this one and this one? Would you think it is positive or negative? Or you think positive and negative? Let us. So this is the question also, 2. This is 90. So I am asking you, if this is 90, this is 4.85% here, 4.85% here. So definitely, this value is positive and this value is negative, isn't it? Because the middle is 90%. What is remaining? 10%. Partly here and partly here. The Z value could be positive and negative, but both of them are the same. So which one is easier to find, this one or this one from the table? Which one do you think it is easier? The left is always easier. So I go and search for 0.0485 in the table. Once I found this one, I just simply put a positive here. So I go to the table, I try to find 0.0485. To the left of this, if it is 0.0485, what is the Z value? 0.085, the Z value would be minus 1.66. Minus 1.66. So I found minus 1.66. What is the other way that if you want to find this positive one? What do you think that you would do if you decide, no, I want to use this one? What do? You could check for probability 0.930 plus this one. If you want to find this one, it is okay. 9030 plus 0.04, you go to the table and try to find it. But this is the easiest, I think. So this is how you read, minus 1.66. So this is a little bit exercise I gave you. So the question is asking at what level of, so the question is now asking x. We know that z equals x minus mu divided by sigma. The question here is that tell me x, what is the value of x? From this one, exceeding 90%, I could calculate z. I could find z. So let us do that quickly. Information, this is given, this is given. Again, this information is given. Exceeds 90 percentile. 90 percentile would be almost the whole is 90 percentile. Only 10% is remaining. So I have to find the 90th percentile z value, because z equals x minus mu divided by standard deviation. Standard deviation is given, mu is given. I need to find z. Once I find z, I could find x. So I need to find this one first. So I found it this one. 90% is this one. If I go to the table, 90%, it would be somewhere here, 90%. 90% is 1 minus 1.28. So this helped me, this information, 90% helped me that it is 1.28. Now I have z value. If you have z value, then it is easy to find x. I will try some of the information that I upload to upload it, some of the things that I tried to show you, but not in your lecture note. Probably I will upload them, the extra information that you don't have in your lecture note. Okay. Now, this is the information that I gave you. The normal distribution could be used to approximate a normal binomial distribution. The question is binomial, but we use normal distribution in order to approximate it, in order to find the answer, not exactly, but approximating it. So, because a normal distribution is easy to calculate, we could still use for a binomial distribution. Let us take a binomial question. N 12, P 0.5, Q 0.5. You remember from lecture 1, mu is equal NP, and sigma is the square root of NPQ. Sigma is the square root of NPQ, and mu is NP. We know that. Now the question is a binomial. Recall that one of the reasons why the normal distribution is vitally important is it can be used to approximate. The question is binomial, but because the binomial question takes a lot of time to us to calculate, we simply use the normal distribution formula. Z equal x minus mu divided by sigma. We could apply that one to approximate. We don't get exactly the same answer, but we get an approximation. Let's say now the question, you have 12, the question is greater or equal to 8. So in a binomial, you calculate for 8, you calculate for 9, 10, 11, 12. The sum would be 0.1937. This is in a binomial how you would do if I ask you in your exam. But this is a lot of calculation. Why don't we do it simply one formula? Using Z equal x minus mu divided by sigma. But one thing that you shouldn't forget, we have to do a normal a correction, a continuity correction. The question is binomial, but we are applying a normal distribution formula. So because of that, we have to make a correction, a continuity correction. So if the question is greater or equal to 8, first you have to reduce this one to 7.5. If it is greater or equal to 8, you have to write 7.5. What about if it were less or equal to 8? Then the correction would be 8.5. If it is less or equal to 8, this would be 8.5. If it is greater or equal to 8, this would be 7.5. Why do we make a correction? And why it is only 0.5, we'll talk a little bit next week. But a correction is needed Because the question is binomial. We are using a normal distribution formula. So once you do that, you see I made the continuity correction. The mean is 6. The standard deviation is 1.732. Easily, I calculated 0.87. When I found 0.1922. Anything greater would be 1922, which is somehow 1937. I try to approximate the answer, but in a very quick and simple way. Keep in mind, you have only 12. If we have 30 or 40, we should have calculated so many. So we make life a little bit easier. When I say to you this one, because this is developed when software were not there. Nowadays, the software could do that. You don't need even the continuous. You could still use the binomial because the Excel or any kind of software could do that. But in a previous time where there were no software, the easiest way is simply to apply the formula of Z, but you have to make a continuity correction. You see why? If you see this dot point, dot is binomial, smooth is normal curve, so they almost look alike. That's why we are using the normal approximation, because if you see the dot points, which is binomial, if you see the smooth line, which is normal, they almost look alike. So it is reasonable to use a normal distribution formula for a question which is binomial. So keep in mind, in your exam I might ask you, this is a binomial question, please use the normal approximation to answer the question. So don't use the binomial to answer. I am asking, use the approximation. Okay, now the possible correction, continuity corrections. This is fine. These are the possible, maybe it is not in your lecture note. You could simply look at it, but then I will upload them. If it is equal to 6, this question, if this question were equal to 6, then you make continuity correction 5.5, 6.5. If it is greater than 6, what does it mean? Greater than 6 means the same thing, greater or equal to 7, isn't it? If I say greater than 6, the same thing, it is greater than or equal to 7. So the continuity correction is 6.5. If I say greater or equal to 6, the correction 5.5. If I say less than 6, which means less than or equal to 5, the correction would be 5.5. If it is less or equal to 6, it means 6.5. So try to familiarize yourself how the correction works. In your exam, probably, if I give you only this one, please don't forget, this means this one. Less than 6 in a discrete, if you say, for instance, I have less than 6 brothers, you are saying you have 5 or less. If you are saying I have less than 6 brothers, or if you are saying I have less than 6 TV, you are saying 5 or less. So think about this first, and then once you have this one, make the continuity correction. Because sometimes students, they would write 6.5 or something. So if you do 6.5 is wrong. So think about the red ones. Okay, this is the question. If it is between 90 and 100, then you get a little bit 89.5, 100.5. If it is exactly 50, 49.5, 50.5. Exactly 50 means the same thing, exactly 50. 49.5, 50.5. At least 67. So all things are given here. At least 67 is the same thing, this one. At least 67, 67.5. No, this is at most. At least 67, then 66.5. At most 67, the maximum is 67, the same thing, the maximum is this one, then you reduce 6.5, which means 67.5. So if you follow this one, it will be fine. Huh? So I will upload this one. Now let's go to the sampling distribution. You see, in the previous, what I told you is that we are picking from the population one random variable. We are picking only one. But in reality, we don't do like that. We don't pick only one person. We take a sample. Now the question is that, if this is the formula, and we want to take a sample. Should we have to use the same formula, or the formula has to be changed? One thing that it comes to my mind, if I take a sample, instead of x, I have to use a sample mean, because I am taking a sample. This one is only you are picking one person. This one is any normally distributed random variable. If you take a sample of students, and I am talking about their height, one thing that I am sure, I have to change this one to x bar. X bar means the sample mean. What about this one? Do I have to change this one? Do I have to change this one? How do I know? This formula is, I know when the question is simply, I picked one person from the population. If it is about weight, I pick the person, I measure the weight, then what is the probability less than this weight? What is the probability greater than this weight? What is the probability between this weight and this weight? But now I am taking a sample. If I take a sample, am I going to use the same formula, or something must be changed? Definitely something, this one definitely would be changed, because I am now talking about sample, so I have to take a sample mean. What about this and this? So a short answer, this will not be changed, but this has to be changed. This will not be changed, and this has to be changed. For example, consider a very large normal population. Assume we repeatedly take samples of a given size. I take a sample of 5, sample of 5, sample of 5, sample of 5, all possible samples from the population, and calculate the sample mean for each sample. Different samples will lead to different sample mean, definitely. The mean of height here, the mean of height here, the mean of height here is different, definitely. Different samples will lead to different sample means. But the distribution of these means is the sampling distribution of the sample mean. I could distribute. I have a mean of 5, mean of 7, mean of 4, mean of 2, mean of 10. I could distribute them. I can make a sampling distribution. This distribution will be normal. So if the whole class, height of the whole class is normally distributed, you see the population is normally distributed. I take 10 students, I ask their height, another 10 students their height, another 10 students their height, so many different samples. I calculate the mean height, mean height, mean height, mean height. If I try to distribute, they will look normal distribution. Why? Because the population is already normal. If the population of height of all these students is normal, the sampling distribution would also be automatically normal, because the population is normal. But the central limit theorem is saying that don't worry about whether the population is normally distributed or not. We don't care. As long as the sample that I am taking is large enough, then the distribution would be still normal. So what this one is saying, that as long as your sample, if you take enough sample, we don't care whether the height of the whole students is normally distributed. Regardless, if it is normally distributed, fine. Any sample size would be fine, will be normally distributed. What about if the population is not normally distributed? Then you have to have a large sample size. Then the question comes, how large? How large, if your sample is greater than 30 and the population is not normally distributed, don't worry, your sample would be also normally distributed. If it is symmetrically population, but if the population is a little bit symmetrically distributed, still greater than 15 would be fine. The last one, if the population is normally distributed, we don't care about the sample size. 10 sample size would be enough, 5 sample size would be enough. So now the whole idea, I will take you back whether we will use the same formula or not. So, as I told you, this one would never change, but this one has to be changed. We are no longer using the same formula like this. This would be changed to x bar. This would be not changing, would remain the same, but this has to be changed. It has to be divided by the square root of n. Why? Now let us take one practical example. Let us assume the population has only 3 values, 1, 2, 3. This is the population, the whole. 1, 2, 3. And let me calculate mu and sigma. So I calculated the population mean is 2. The population standard deviation is 0.82. So I know the population values, population mean, population standard deviation. I know both of them. Now, I take a sample of 2. Because the population is 3, let me take a sample of 2. All possible samples with replacement. Keep in mind, population mean 2, population standard deviation 0.82. So I am taking a sample with replacement. The first sample is 1 and 1, 1 and 2, 1 and 3, 2 and 1, 2, 2. These are the whole possible sample size of 2. The population has only 3 numbers. I take a sample of 2. I calculated the mean. When I calculate the mean of all sample means would be equal to the population mean. The mean of all sample means, this is mean. This all are means. 1 plus 1 divided by 2. 1 plus 2 divided by 2. 1 plus 3 divided by 2. The mean of all sample means would be equal to the population mean. So the mean of all possible sample means would be equal to the population mean. But the standard deviation of all possible sample means are not be equal. It has to be this way. This might be a little bit of confusing here, but let me give you one slide which I didn't post it, but let us see this one. The same thing. The only thing that we have to calculate is you have already this one. So there are 2 ways that you could calculate mean. The mean of all possible sample means equal to 2, which is population mean. The mean of all possible sample means equal to the population mean. The other way that you could calculate, this is 1. How many possibilities do I have? 1, 2, 3, 4, 5. The probability is 1 over 9. For this one, 1.5, the probability is 1.9 because there are 9 possibilities. 1 over 9, 1. If you calculate this way, you would find 2. Now I am calculating the variance. You see, when I calculate the variance that I calculated based on my sample, I calculated variance. Based on the sample, I calculate the variance. My variance is 0.33. Then I calculated my sample standard deviation. My sample standard deviation is 0.58. Now, instead of doing that, I could find this one, this number, I can easily find it. Keep in mind, it is 0.82. I can find this number just simply by making 0.82 divided by n. I have 2 numbers always, two numbers. So if I make the population standard deviation divided by the square root of n would give me the same value. It would give me the same value. So the formula at the end, the formula that I have to use, has to be converted to this one. This one, I don't have any problem because it gives me the mean 2. This one, I have a problem. The answer it gave me, my sample gives me 0.58. This one, in other words, it means that the population standard deviation divided by the square root of 2. So I can use this formula. So finally, this is the formula that I am going to use. Probably we haven't finished, but we will do a little bit next week. So now we are starting to talk about the sample to calculate probability. Take one example. A manufacturing of automobile batteries claims that the distribution of the lengths of life, this is the claim. So 54 is the population mean. 6 is the population standard deviation. Now, a sample of 50 taken, and you want to calculate 52 or fewer. So the information here given is the population mean, 54, population standard deviation, 6, sample size, 50, the question, 52 or fewer. If you have this information, we could apply this formula. 52 or fewer is the question. 50, this is 54, this is 6. So 52, the question, 54, given, this is given, I know my sample size, then minus 2.36. Anything to the left of 52 or fewer means to the left of minus 2.36. If you go to your Z table, you look 2.36, you will find the probability 0.91. Don't worry about these things, but let us talk only about the probability calculation. Let's do another example, which is exercise. A random sample of 81 is drawn from a population. The population has a standard deviation of 12. The sample is 81. If only 18% of the time a sample mean greater than 300 is obtained, what is the mean? Now the question is that tell me the mean value. So this information is a little bit sometimes confusing, but let us do it together. If only 18% of the time a sample mean greater than 300. A sample mean greater than 300, 18%. A sample mean less than 300 would be 82, the opposite. So when I go to this one, 82, this is 18% greater than 300, 82% less than 300. When I go to the table, I found this value. This value, which is 82%, this is 18%, this is 82%. When I go to the Z table tells me it is 0.92. Keep in mind 82%. 82%, 0.82. 82%, 0.92, 0.92. So I found Z, 0.92. 300 mu, this is what the question is. So it's possible to calculate that. You see, 18% is given here. Then it means 82%. So for me, it is easier always to calculate to the left because my Z table always calculates to the left. So I take 82% because I want to find the Z value here. The Z value here. So I went to my table, try to find 82%. The 82% gives me the Z value of 0.92. Once I have that one, I could answer the question because the question is a population mean. So I go here, 300 is given, 81 is sample size, 12 is the population standard deviation, finding this one, and this is 2. So this is, you see, the population mean, the center, the population mean. This is the population mean. This is X score or Z score, this value. This is Z score or X score. The center, this is X score. What is the Z score? What is the Z score here? 0, yeah, 0. The standardized normal distribution. Okay, so we almost finished, but I will show you how to do in the case of proportion also. It is this way. I will come to this next week, but this is the main thing also in the case of proportion. If you could give me 1 minute. Huh? You see, we know the proportion is X divided by N. What is the proportion of students who are female? Number of female students divided by the total, isn't it? What is the probability, or what is the proportion of students who are from China? Number of Chinese by number of students. So this, we know this mu and p, we know this one, the square root of n pq. Now, proportion. The proportion is X divided by a number of Chinese students divided in the sample. How many Chinese students in my sample? X divided by n. And because I am dividing by n, I also divided by n. Everything will be divided by n. At the end, I could use this formula if the question is about the sample. The same thing that I use Z equal X bar divided by mu, divided by the sigma, and then divide by the square root of n. Maybe I will do it next week. Yeah? Thank you so much for your attention. It's a lot of material, but we will deal with that. No problem.